Hi all, today I'm talking about how to use truth tables to determine whether an argument is valid or not. So by the end of today's class, what we'll be able to do is, given an argument like the one you see on the page here on the left, if O then not T, if not T then B, therefore if O then B. By the end of today, we're going to be able to figure out if this argument is valid or not using the truth tables that we've already learned how to produce. So up to this point, we've learned how to translate propositions from English into our symbolic language and how to use truth tables to figure out if individual propositions are tautologous, self-contradictory, or contingent, and given multiple propositions to see if they're logically equivalent, contradictory, consistent, or inconsistent. Today, we're just using the tools we've already developed to figure out if arguments are valid or invalid. So given this argument, the first step we need to take is right up here. We need to rewrite the argument horizontally with slashes between premises and a double slash between the last premise and the conclusion. So here it's written in a vertical pattern with the premises above the line, the conclusion below the line. We're going to have the premises and conclusion written horizontally with between premises we'll have a slash, and so here's one premise slash, here's another premise, and the last premise between that and the conclusion, we have a double line. So double slash and then the conclusion there. All right, and if we were going, so we're going to be using a truth table to figure out if this argument is valid. The next step will be determining the number of lines in our truth table, and it's the same formula that we've been using. So we count up the unique variables from left to right. So we have an O, a T, and a B. So the O appears first, then we have T, and then we have another T, so we don't count the second one. Then we have a B, and then we have another O, but we already counted O, and then we have another B, but we don't count the second instance of these variables. So we have three unique variables, and the equation for the number of lines is 2 to the n, where n equals the number of unique variables, and n in this case is 3. So it'll be 2 cubed, or 2 to the third power, either way of saying it. So 2 times 2 times 2, so our truth table will have 8 lines. So we then go to the next step. And the next step, just like when we were doing single statements or single propositions or multiple propositions, we're going to construct our truth table. So we put the cross here, we put our cross, we make our truth table. In the left hand, on the top left of the cross, we put all the unique variables in the order that they appear throughout the whole argument. Then up here we put each premise and the conclusion separated by a single slash and a double slash. And then in the bottom left part of our cross, we fill in all possible truth values of O, T, and B. The way we do that is we go to the statement variable to the far right. We alternate true, false, true, false, true, false, true, false all the way down. Then we double the number in the row for the T column. So we had 1 in a row for the B column, 2 in a row for the T column. So true, true, false, false, true, true, false, false. We had 2 in a row for the T column. We have 4 in a row for the O column because we double it. 4 true, 4 false. That gives us all combinations of truth and falsity. And then we start solving for all of the propositions in the table. In order to save us some work, I'm going to recommend that we think a little bit about what we're looking for before we start solving for all the propositions. What we're looking to see is if this argument is valid. What does it mean for an argument to be valid? It means if the premises are true, if all the premises are true, then the conclusion must be true. So what would show that an argument is invalid? If we could find a set of truth conditions for the statement variables such that all the premises were true and the conclusion was false. In that case, that line would demonstrate that the argument is not valid. Why? Because there's a possible combination of truth values such that all the premises are true and they failed to guarantee the truth of the conclusion. So if we're looking for all true premises and a false conclusion, what I'm going to recommend that we do is we do the conclusion first and see on which lines is the conclusion false. We can skip right over the lines on which the conclusion is true. Why? Because what we're looking for is true premises, false conclusion. If we're not getting that, then the argument is valid as far as we know. So we're trying to catch this argument red-handed. Catching it red-handed entails finding a line where the premises are true and the conclusion is false. That's our smoking gun. If we find other things like a false premise or a true conclusion, we don't care about that line. That's not the smoking gun we're looking for. We just would skip it and go to the next line. We're looking for that evidence. So let me go through this table in the way that I would. So I'd go straight to the conclusion and I'd see that the conclusion is O horseshoe B. So on this line, O is true and B is true. So when the antecedent is true and the consequent is true, a conditional statement is true. So on this line, the conclusion is true. Why is this striking through? Doesn't matter. I would strike it through anyways. So this conditional statement is true on this line. The conclusion of this argument is true on this line. So I know that that's not what I'm looking for. I'm looking for a false conclusion. And if I have a false conclusion, I'll go to see if the premises are true. Here the conclusion is true, so now I just skip down to the next line. On this second line, O is true and B is false. So on this line, this conclusion will be false. So now that I have a false conclusion, I have to go see, do I have true premises? Because if I have true premises and a false conclusion on one of these lines, I've demonstrated that the argument's invalid. So now I go to the premises. On this line, I'll go to this first premise. So O horseshoe tilde T. So O is true and T is true. So if O is true and T is true, the tilde in front of the T would flip the consequent of this to false, so I'd have true horseshoe false. And true horseshoe false is the only time that the horseshoe is false. So now I can strike this entire line through. Why can I strike this entire line through? Because it's not giving me what I'm looking for. What I'm looking for is all true premises and a false conclusion. And I had a false conclusion, but then on that same line I had a false premise. So this won't be the smoking gun for this argument. So I continue on down. On line 3, O is true and B is true. So then I'll have true horseshoe true up here. And that is true. So I don't care about that line. On line 4, O is true and B is false. So I'll have true horseshoe false. So that's what I'm looking for. I have a false conclusion. So far so good. Maybe this line will give me the smoking gun and demonstrate that this argument is invalid. But in order to do that, I would need true premises. So let's look at premise 1. Premise 1 says if O, then not T. O is true and T is false, but the tilde in front of the T would flip that to a true. So I'd have a true antecedent and a true consequent. So I'll have a true premise. So far, so good. This line might show that this argument is invalid, but so far I only have one true premise. I need both of the premises to be true while the conclusion is false. So let's go to the second premise. In the second premise, I have tilde T, horseshoe B. B is false and T is false, but the tilde will flip that to true. So I'll have a true antecedent and a false conclusion. Unfortunately, that is a false premise. So this again is not what I'm looking for. On this line, I had the false conclusion, but I didn't get the true premises. So this won't be the line that shows that the argument is invalid. Now, for every other line in this truth table, we see that O is false. And when O is false, that means I'll have a false antecedent up here, which means I'll have a true conditional statement. So none of these lines will give me what I'm looking for. So my final truth table would look like this, and I would see that either the conclusion is true, or when the conclusion is false, then one of the premises is false. So I have no line on which all the premises are true and the conclusion is false. I tried every possible combination of truth values for the statement variables. So this argument is valid. It's never, if the premises are true, they would guarantee the truth of the conclusion. There's no case where the premises are true and the conclusion is false. So if I were doing this on a test, the answer would be valid. Let's do one more example. So say I had this as my argument. So C triple bar D, E or not D. If E, then C is my conclusion. So two premises and a conclusion. I already took the first step of rewriting this argument horizontally with slashes between the premises and a double slash before the conclusion. Next, I have to determine the number of lines on my truth table. C, D, and E are the three unique variables. So I'll have 2 times 2 times 2 is 8. I'll have 8 lines on my truth table. So now I need to construct my truth table. If I do so, I do it like this with the premises in the order they appear. So C, D, and E. I'll have, that's in the top left of my cross. In the top right, I have the argument separated by slashes between premises and a double slash between the last premise and the conclusion. All right. I then fill in all possible combinations of truth values for the statement variables. Alternating true and false for the column to the right, 2 true, 2 false for the middle, and 4 true and 4 false for the one to the left. If there was another statement variable, then it would be 8 in a row true, 8 in a row false. Then I figure out if this argument is valid, I'm looking for, recall, true premises and a false conclusion. So I'm going to do the conclusion first. And I'm going to see my conclusion is E horseshoe C. When is E horseshoe C false? When E is true and C is false. On what lines am I getting that? E true and C false. On line 5, I'm getting that. And on line 7, I'm getting that, where E is true and C is false. If these shortcuts are going too fast for you, you can go through every other combination of truth values for this conclusion, and you would see on every other line they're true. For example, true, true on this first line. E being false, so true on this line. Them both being true on this line, so true. E being false, so the conclusion's true here. E is false here, so that line is true, and so that conclusion is true, and E is false here, so that conclusion is true. These are the only two lines that I'm going to get a false conclusion. So now I need to see on those lines, do I get true premises? So let's look at premise 1 here. On premise 1 on line 5, I have C being false and D is true. So I have false, triple bar, true. And recall that the triple bar is only true when the things on both sides of it are true. So this one has false on one side, true on the other, so this is going to be false. So I have a false premise, so unfortunately this is not the line I'm looking for. I only have one more possibility, and that's on line 7. So will this line show that it's invalid? I have a false conclusion. Let's go to the premises to see if they're true. If C, on this line, C is false, and D is also false. False, triple bar, false is going to be true, because the triple bar is true when the things on opposite sides of it are equivalent, so it's false on both sides, so the triple bar is true there. So it's looking pretty good. I have a true premise, I have a false conclusion. If I have another true premise, then this argument is invalid. So on this line, E is true and D is false. So D is false, but this tilde will flip that to true. So if D is false, then tilde D is true. And then I have true, wedge, true. If I looked at the truth table for a wedge, I'd see that when both sides of it are true, then it's true. Or another way of putting it more succinctly is as long as at least one part of the wedge is true, then the wedge is true. So this is true. Now look what I have. I have true premise, false conclusion. This argument is invalid. If I were asked which line showed that it was invalid, I would say line 7. So how do I know this is invalid? Well, the truth of the premises does not guarantee the truth of the conclusion, because you can have true premises and a false conclusion. In fact, you do on line 7. If C is false, D is false, and E is true, then you'll have true premises and a false conclusion. So the answer to this problem would be invalid. So that's all we need to know how to do for the chapter. Now there are some interesting consequences of how we've been trying to figure out if arguments are valid or not. Recall that we said an argument is valid if whenever there are true premises. So an argument is valid if and only if, whenever there are true premises, there is a true conclusion. Or another way of saying that, true premises guarantee a true conclusion. Only if true premises guarantee a true conclusion. So an interesting thing that falls out of this is if you have an argument with a premise that's self-contradictory, meaning which is always false, or if you had two premises that contradicted each other, so they weren't both true, or they were inconsistent, so there's no line on which they're both true, then you automatically have a valid argument. Why? Because there'd be no line on which the premises were true and the conclusion was false. So interestingly, you can create a valid argument for any conclusion as long as you have inconsistent premises or a self-contradictory premise. So for example, I could create a valid argument for God's existence. The light, like imagine I was holding up a light bulb and I said, this light bulb is on and it's off. Therefore, God exists. Those premises are inconsistent. Or if it's one premise, stated as one premise, it's self-contradictory. So I would never have a case where the premises were true and the conclusion was false, so that would be a valid argument. Now that's just a little trick of logic, right? Because if somebody presented you with that argument, you would say, well, look, it may be valid, but it can't be sound. Why can't it be sound? It can't be sound because the premises are either self-contradictory or inconsistent, depending on how you spell it out. So yeah, it's great that it's valid, but validity isn't the be-all, end-all. What I'm looking for are sound arguments, because I know if an argument's sound, then the conclusion must be true. And somebody can present you with a valid argument, like I just did, that is uninteresting. So similarly, you could construct a valid argument that God doesn't exist. The light is on and the light is off, therefore God doesn't exist. Valid, but cannot be sound because the premises are either self-contradictory or inconsistent. Little weird trivia thing, and if you want to impress your friends with weird logic tricks, then go ahead and do that. But they will end up frustrated, and you might end up too, so, maybe don't. Anyways, that's the end of this lecture. Today we learned how to figure out if arguments are valid using truth tables. I hope that's clear now. See you next time.